In this video, I want to review some formulas that you need to know when dealing with inclined planes. Now, let's say if you have a box that rests on an incline. The force that extends perpendicular to the surface, this is the normal force. The weight force is in the negative y direction as always, so that's mg. Now let's say we have an angle. Now what you want to do is you want to draw this line, but in the other direction. And you want to draw a triangle, making this the hypotenuse of the triangle. So it's important to understand that this angle is the same as this angle. For instance, let's say if this angle, let me see if I can fit it in here. Let's say it's 30. And this, we can see it's 90, which means this has to be 60. And this is perpendicular, like this line is perpendicular to that line. So which means this is 90 as well. So therefore this part has to be 30. Which means theta is right there in that triangle. So let's focus on that triangle. Now, let's say this is, let's call this x and let's call this y. In terms of mg, what is x and what is y? What would you say? Perhaps you heard of the term SOHCAHTOA in trigonometry. So the first part means sine is equal to the opposite side divided by the hypotenuse. And this is cosine is the ratio of the adjacent side of the right triangle divided by the hypotenuse. And tangent is the ratio of the opposite side to the adjacent side. So cosine theta is going to be equal to the adjacent side divided by the hypotenuse. So that's x over mg. Now if you cross multiply and solve for x, you'll see that x is mg cosine theta. So therefore, this portion is equivalent to mg cosine theta. And because the block is not accelerating upward or downward, in this direction, we'll call it the y direction. Let's call this the x direction. In the y direction, the net force has to be 0, which means that these two must be equal to each other. So for a typical inclined problem, the normal force is equal to mg cosine theta. So make sure you know this equation. Now let's focus on sine theta. Sine theta is the ratio of the opposite side, which is y, and the hypotenuse. So sine is y over the hypotenuse, which is mg. So if you cross multiply, you'll see that y is mg sine theta. So that correlates to this portion of the triangle. Now, it turns out that there is a force that accelerates the block down the incline. So that force, I like to call it Fg. And notice that it's parallel to this part of the triangle. So it turns out that Fg, the component of the weight force that accelerates the block down the incline, is mg sine theta. So that's another equation that you want to use when dealing with inclined problems or inclined plane problems. Now let's say if you have a block that rests on a frictionless incline and you want to find the acceleration, how can we derive a formula to do that? So once again, what we're going to do is we're going to define this as the x direction and this as the y direction. The only force that's accelerating it in the x direction is Fg. So the net force in the x direction is Fg because that's the only force there. Now, according to Newton's second law, F is equal to ma. The net force is always the product of the mass and the acceleration. And we know Fg is mg sine theta. So to find the acceleration down the incline, we don't need to know the mass of the block. It's independent of the mass of the block. So the acceleration down the incline is simply g sine theta. It's dependent on the angle. And so this is the equation you want to use. Now sometimes you may have to deal with friction. So let's say the block is sliding down. It's moving in a positive x direction. Where is friction located? Now we know Fg is going to be down as well. But friction always opposes motion. So if the block is sliding down, kinetic friction will oppose it, and so it's in the opposite direction. So now, if you want to find the acceleration, we need to start with this expression, the net force in the x direction. Now this is in the positive x direction, and this is in the negative x direction. So this is going to be positive Fg plus negative Fk, or simply minus Fk. Now always replace this with ma. Now we know Fg is mg sine theta, and Fk, the kinetic frictional force, is mu k times the normal force. So make sure you know this equation. And the static frictional force is less than or equal to mu s times the normal force. Now we know the normal force, as we mentioned before, is mg cosine theta. So therefore ma is equal to mg sine theta minus mu k times mg cosine theta. So once again, we could cancel the mass in this problem. So when dealing with friction on an inclined plane, the acceleration is going to be g sine theta minus mu k g cosine theta. And so this is the formula that you want to use. Now what about if we have a block that is sliding up the incline? How can we calculate the acceleration of the system? How can we derive an expression for it? So it's sliding in the positive x direction. Fg is always going to be pulling the block down. Gravity pulls things down. So this component of the weight force is going to cause it to go in the negative x direction based on the picture that's presented. And the frictional force will always be opposite to the direction of motion, so friction is also pointing in this way. So therefore, for this example, the net force in the x direction is going to be negative Fg minus Fk, because they're both going in the negative x direction to the left. So the formula is not going to change. The only thing that's changing is the signs, if it's positive or negative. So therefore, the acceleration is going to be negative g sine theta minus mu k g cosine theta. So these two are working together to slow down the block. Now, how would the situation change if the block is sliding up the incline, but the incline is in the reverse direction? So Fg will still bring it down, and Fk will still oppose the block from sliding up. But this time, they're pointed in the positive x direction. So therefore, it's just going to be Fg plus Fk. So in this direction, acceleration is positive. In the other example, the acceleration was negative. And that's the only difference. So just like before, this is going to be ma, and Fg is going to be mg sine theta. And Fk is mu k times mg cosine theta. And so the acceleration of the system is positive g sine theta. And this is supposed to be a plus. So plus mu k g cosine theta. And so this is it.